Hello dear friends, this is Anas Hamoutni from Math World and this is the first video of this educational channel. I created this channel to share with you guys what I learn on a daily basis in my journey as a mathematician. So this channel will be dedicated to exploring different mathematical concepts and ideas that have a serious impact on our world. And this introduction video will be about proving the strangest sum you will ever encounter in your life as a mathematician, namely the sum of all integers. So you can ask yourself, why is this sum weird? Isn't it just supposed to be equal to infinity? Well, we'll find out together. Just follow me along the video. So let's start by writing our sum until it reaches a certain number, so a certain integer, what we call it n, so little n. So it's a finite sum, but we actually need to rewrite this sum differently in order to calculate it in a simple way. So what we're gonna do is that we're gonna write it in a shape which is a matrix. So what you're gonna do is that we're gonna write one time, two, we're gonna divide it into two ones, so one twice, and three, we're gonna divide it into 3 times 1, so 1 3 times, and so on until we reach the phase n. So we're gonna have n, which is rewritten into 1 n times. So what we actually are seeing here is a shape of a triangle. So it is a triangle which is containing ones and which is a part of a square which we already know the area, which is n squared, because there are n ones in the height and also n ones in the width. So it's height times width, which is n squared, and this n squared is equal to Sn, which is our sum from 1 until n. We're gonna notice Sn plus a certain x, which is the missing area. So the missing area n squared. So the opposite triangle to our first triangle, which sum is Sn. And this opposite triangle is nothing but Sn minus 1. Why? Because if we see in the last or the first, in the last line, we have in total n ones, but there is a 1 which doesn't belong to the opposite triangle, and so we are left with n minus 1 ones. And so we have a length of a width of n minus 1 and also a height of n minus 1. So it's nothing but the Sn minus 1. So the area is just the Sn minus 1, as if we wrote 1 until n minus 1 and we write it in a matrix way. So let me just free some space here. So this triangle, we're gonna not use it anymore, and we are left with our formula. So n squared equals to Sn plus the x, which is just Sn minus 1. Let me rewrite this. N squared equals to, so sorry, it's not plus, it's equals. So n squared equals to Sn equals to Sn plus Sn minus 1. So there is also a relationship between Sn and Sn minus 1, as we are just summing 1 until n. So Sn is nothing but n plus the Sn minus 1. So now let me free just some space on the right. So now we can just rewrite this as n squared equals to Sn plus n minus, plus Sn minus n. So Sn plus Sn minus n. And if we do the calculations and we continue until the end, we'll find that Sn is equal to n times n plus 1 divided by 2. So this is the formula for this part. And let me just free some space here just to ensure that we write the formula in good way. So just I'm freeing some space here, and so basically Sn is equal to n times n plus 1 divided by 2. What we really can conclude here is that this formula, as n goes to infinity, this formula is actually going into infinity times infinity plus 1 divided by 2. And as we are able to compute infinity times infinity according to general mathematical conventions, so we are able to calculate plus infinity times plus infinity, which is plus infinity, divided by 2 is also plus infinity. So Sn goes to plus infinity. And that means that this sum is divergent. So now that we calculated this term and we found that as n goes to infinity, Sn goes to infinity, so basically the sum of 1 until infinity is just infinity, let's do the things differently and calculate this sum in a different way. Now let's start the second part of the calculations. So for this part we have to make an assumption, is that we can actually assign for any infinite sum like this one, we can assign a certain number which might be a real number, so we'll call it C. But for this part we'll start with another sum. In order to calculate this sum, we'll start with another sum. Let me just delete this one. And so the sum we're going to start with is the following one. So 1 minus 1 plus 1 minus 1 plus 1 and on and on. So we go, we'll never. So what's the value of this sum if we suppose that we can assign a real number to it? So if we suppose that there is no such thing as infinity and we can call this sum A, what we can really deduce is that this sum can be 1 minus brackets 1 minus 1 plus 1 minus 1 into infinity. So there's no such thing as infinity, but we assume that we will never stop counting. So this is also equal to a. And with simple observation, we can see that the part between the brackets is nothing but a. So we found the following relationship is that 1 minus a equals a. This follows that a equals to 1/2. So we suppose that we can assign a real number to this sum, which goes without stop, without stopping counting. We found that the possible value that we can assign to this sum is 1/2. So just let's remember this value because we're gonna need it after. Now I'm gonna just free some space here, and we'll do the same with another sum, different sum, which is this one. 1 minus 2 plus 3 minus 4, and we'll go, and we will suppose also that we can assign another value, we call it b, which might be a real number. So under this hypothesis, we'll try to find b. So what we're going to do now is we're gonna bring back our last sum, so which we calculated earlier. So 1 minus 1 plus 1 minus 1. So this one is equal to a, which is equal, as we did before, it's equal to 1/2. So we are just going to sum b and a. This is gonna give, so in the first part, 1 plus 1, which is 2, plus 2 minus 1, minus 2 minus 1, which is minus 3. So I'm just gonna erase this plus sign. Okay, so it's minus 3 plus 4, and it will go. What we actually gonna find now is that this b plus a is something close to b. So this one is really close to this one. There's just a minus sign and a 1 missing. So this is actually equals to this minus 1 times minus 1. So it's b minus 1 times minus 1. So now we can calculate b as being b plus a equals 1 minus b. And because a is equal to 1/2 plus b is equals to 1 minus b, then we'll find that b, so 2b equals 1/2, which means that b is equal to 1/4. So we found that if we assign b to this sum and given that we have already assigned a to this sum and found a equals 1/2, then b will be equal to 1/4. And now we go right away to our last sum, which is 1 plus 2 plus 3 going, and we assume that we can assign a value c for this one. We don't know what c will be, but we actually make the hypothesis that we're gonna assign c for this one. Let's sum c plus b. So it's 1 plus 2 plus 3 plus 4 plus 5, etc. plus 1 minus 2 plus 3 minus 4, etc. So we will be getting just 2 times 1 plus 3, etc. And now we should calculate this one if we want to finish the whole story. So this one is just 2 times c minus 2 plus 4. So basically multiples of 2, which is also equal to 2 times c minus 2 times c, which is equals to c plus b, of course. So now, if you want to continue calculations, it will be c plus b equals 2 times minus c, and this will be equal to c plus b equals, so equivalent, this is equivalent to this, minus 2c, which will be 3c. So if we give this term, turn it here, and b will be here. 3c equals minus b. And so c is equal to minus b over 3, and because we already found that b is equal to 1 over 4, so this c is equal to minus 1 over 3 times 1 over 4, and finally c equals minus 1 over 12. Well, what a bizarre sum. Just by making the hypothesis that we can assign a real number to the sum 1 plus 2 plus 3, etc. So just by assigning a real number to this sum, we found that this real number maybe exists and is equal to minus 1 over 12. So what does it really mean? Actually, this is a golden answer, because, well, this answer, just believe it or not, this answer is really working in physics. So in practical physics, in modern theories, when we find that we have this sum and we replace it with minus 1 over 12, well, that's exactly what the experiments are showing. So in real world, when we have this sum and we replace it with minus 1 over 12, then our calculations are right based on experiments. And this is really strange, because this sum is positive, right? and this number is negative. So how come that we found not even a real number, but a more stranger number which is negative? So maybe that's in our world, maybe. So when we write just the line of R, so basically the line of real numbers, so the axis, the x-axis. So it just seemed like R is going to the right infinitely, so infinitely to the right. And we never conceived that maybe R is just going to a certain number and then turning back to minus infinity. Maybe R is not a line, maybe R is something else. So that's the very last of this video, and thank you for watching, and I hope that you liked the video. If you are interested in more videos, just tell me in the comments. And if you are interested in more videos about this concept of the infinite sums which are assigned to real numbers, also just tell me in the comments and maybe we will do more videos. And that's all for this video. So thank you and goodbye.